Hey, good morning, everyone. So today we're gonna keep talking about lines, but we're gonna keep hammering that idea of what it means for something to be a solution, and then we're gonna take our lines a little bit further today to inequalities. So the first case we're gonna talk about is equality. So when I think about points as solutions, I'm thinking about a line in particular. So when I say equality, I mean something like, let's say I give you this. So we're talking equality because we're saying that this side equals this side. Now, the next question is, I want to know which points are solutions. And in this case, I'm just going to give you two and we're going to check it. All right, so the 2 points I'm going to look at are 4, -1 and 3, 2. So there's two ways we can check this. The first way I want you to think about is algebraically. That's just a fancy way of saying that, remember, a point is xy. So if I have my equation here, instead of y, I'll use my triangle square setup. Instead of y, I'm just replacing y with its y value. And I'm just replacing x with its x value. And then my goal is -1 minus 2, well, is -3. I got parentheses here, so what's 4 minus 10? Looks like -6. -6 times a half. Remember, we can think of this as being over 1, so that would just be 1 times -6 and 2 times 1. That would get me -6 over 2, or -6 divided by 2. And this is true. Therefore, 4, -1, that looks like a 7. 4, -1 is a solution. That's it. So then if we do the same thing, go back to our original, but this time think about 3, 2. Well, in this case, y would be 2 and x would be 3. So all right, and then 2 minus 2 would be 0. 3 minus 10 inside parentheses there would be 7. And you might already be able to see what's happening here. Right away, I should realize that I don't even have to reduce this fraction anymore. I could, it'd be 3.5 if I wanted the decimal, but I'm getting 0 equals something that's not 0. So this is not true. So 3, 2, say that's not a solution. So that's what it looks like algebraically. I'm just taking a point, I'm putting it into the equation, and if I get two sides that are the same, it's a solution. If I get two sides that are not the same, it's not a solution. But let's take a look at this graphically. So, wrong screen. If I take this line and I graph it originally, 4, -1, notice how that point sits right on my line. Therefore, that's graphical proof that 4, -1 is a solution. If I graph 3, 2, notice how 3, 2 is way up here off the line. So how can it be a solution if it's not on the line? So graphically, once again, if a point's on my line for equality, then I know I'm good. If my point is way off the line, then I know it can't be a solution. So this is graphical. this is algebraic. They both prove the same thing. All right, so the one thing I'm going to change is we're going to look at inequality. And you should have seen this before. So I'm going to introduce two symbols. All right, so here's one. And remember, this just means whatever's on the open side of my inequality means that's the bigger one. And whatever's on the closed side of my inequality, that's the smaller one. So this would mean that this number on this side has to be bigger than this number on this side. Or you're going to see it the other way around, but the same property holds. So you just have to know that open side is the bigger number, closed side is the smaller number. All right, and then the only other thing you might have to worry about is same symbol, and all that means is this is either the bigger side or it's equal. So that's the big thing. If you see this little bar, it's saying that this number, the numbers can be bigger, smaller, or they can be equal to each other. And just like the other one, if I reverse the symbol, that just reverses which side is bigger and which one's smaller. So this is critical here to know that the numbers have to be bigger, smaller. This one can be bigger, smaller, or equal to each other. All right, so let's take a look. Once again, I want to know which points are solutions. So here's my equation, or sorry, here's my inequality, I should say. All right. So now I want to look at which points are solutions. All right. The first one I want us to think about in this case is going to be 12, 0. All right, so same rules apply. Here's x, here's y, so I'm just going to go to my inequality and I'm going to say, all right, I know y is 0. And I know that this is going to be 12. So just replace x and y. All right, and then let's take a look. So can't do anything here because it's two different sides. So my properties are still holding just like equality. It's just I have an inequality symbol. All right, I'm thinking about this as 12 over 1. So 12 times 2, 3 times 1, that's going to be 24 over 3 minus 7. Or 0 is less than 8 minus 7. Or 0 is less than 1. So 0 is the smaller number. 1 is the bigger number, so this checks out. So all that tells me is 12, 0 is a solution. All right. Cool. So the second point that I want us to think about is what if I give us 15, 8? So same thing, think about that as xy. So my y value is going to be 8. My x value here is 15. So two sides still. Here's 8. Sorry. Ignore my sloppiness here. So thinking of this as 15 over 1, 2 times 15, 3 times 1. That'll be 30 over 3 minus 7. 30 divided by 3 is really just 10. Minus 7. And so this says 8 is smaller than 3. 8 smaller than 3. Clearly not true. So that is going to tell me that 15/8 not a solution. All right, so the only difference is just recognizing your inequality is saying one side's bigger or smaller than the other. And since in this case, this results in 8 being less than 3, which isn't true, this can't be a solution. But now let's look at that graphically. So inequalities are a little bit strange because this is saying that the y side has to be smaller than whatever I get over here. And so visually, this is going to be a little bit striking. So I'm going to close this out. All right, so once I click this, sorry, wrong way. All right, so once I click this, notice how this whole region down here is being shaded. So if I take the first point we said was a solution, 12, 0, first it's not showing up. So if it's not showing up, remember that's going to mean that it shows up somewhere else. Notice how 12, 0, we said before, is a solution because it resulted in something that was true. Notice how this point, although it's not on my line, it's in the shaded area. So with an inequality, anything in the shaded area is going to actually end up being a solution. So I'm not restricted to the line itself. I'm restricted to anything within the shaded area. Now, if we take a look, we said 15/8 was the other one. Let's check out 15/8. Notice how 15/8 does not show up in the shaded area. It shows up in this unshaded space. And algebraically, it showed up as not being a solution because 8 is not less than 3. So with that said, notice how this line here is dashed. And let's say I take a point, let's say 15/3. I'm going to change this to 15/3. Because this line is dashed and because this is a less than symbol, if a point is on a dashed line, it is not a solution because less than means that whatever point is a solution has to be in the shaded area but not on the line. Notice how if I change this to an equal, now it's less than or equal, this becomes a solid line. Now this point would be a solution. So the difference is anything on the line in an inequality is a solution if it's also equal to the line, but if it's not equal to the line and it's dashed, that means anything on the line is not a solution. So we'll talk more about that, but when you test things algebraically, you'll see something that's not true or true depending on what this inequality is. But if you have some questions as you're thinking about that, definitely reach out and let me know. Otherwise, good luck, and as long as you do things today, I'll have feedback for you tomorrow.